Hello, welcome to the Vermont Public Service Department training of the new Commercial Building Energy Code standards to be implemented early 2020. This code, known by its acronym CBES, is applicable to new construction of 4 stories or higher. It includes multifamily for these sized buildings. These trainings occurred in various locations throughout Vermont in May and June of 2019. The following presentation is Section 403, Building Mechanical Systems. This presentation covers the major changes to the new code. And those changes that we're going to be talking about today are a new definition of the cold climate heat pump, new allowances for heat pump systems, equipment sizing, some efficiency increases for different mechanical systems, ERV requirements, part load control requirements, economizers, fan efficiency increases, and fractional horsepower fan motor efficiency requirements. In general, the organization has changed to match the IECC 2018 organization of this section. All mentions of the International Mechanical Code have been removed since Vermont does not have that as one of their required codes. And I wanted to just point out that the changes to this mechanical section focus on matching equipment size to building loads and using more energy recovery and variable speed drives to really match the efficiency to the load. The equipment efficiency levels themselves, you'll see, have not changed very much, and they are dictated by federal standards, which is something that the states cannot change. So for that reason, the actual efficiency ratings of the equipment are not very different from 2015 CBES. The other thing I'll point out, which is at the top of this slide, is that in section 403.1 in general, there is a reference to the additional efficiency package option, section C406, that we just wanted to call attention to. It was in the code before. We just wanted to make sure that designers don't miss that additional requirement under that section. So we've stipulated it here. So the first change to this section is the addition of the option for an all-electric building for the HVAC design. With some restrictions, the building can be designed without fossil fuel heating systems. The restrictions lie in the efficiency and capacity at low outside air temperatures and better building envelope. So we'll cover those in a minute. The definition of the heat pump itself is given in the definitions section, and it states that the unit must be able to satisfy the full heating design load at an outside air temperature of 5 degrees with a minimum COP of 1.75. And this is stated so that the electric resistance backup has minimal operating hours. The other addition regarding the cold climate heat pumps is section 403.2.3, which is the electric resistance space heating. As the 2015 CBES has, the electric resistance cannot be used for baseboard radiation heat pump reheat coils, duct coils, boilers, outdoor air intake grills, and coils and terminal units. The exceptions are multifamily buildings with heat loads less than 6 BTU per hour per square foot at design temperature. And then we added this cold climate heat pump exception where, again, the full heating demand must be met by the heat pump at the efficiency, the stated minimum 1.75 COP at an outside air temperature of 5 degrees, plus the building thermal envelope must be a tad better than the envelope section of the code, and it must be not greater than 0.2 CFM per square foot, including all 6 sides of the building at 75 Pascal. The exception number 2, the replacement of existing electric resistance unit, has been moved to existing buildings. It has not been deleted, it's just been taken out here. And that is the same with domestic hot water heaters, has been taken out here in the first section, or the first line of this section, because it's being addressed in the domestic or the service water heating section of the code. The other part that goes with this heat pump design is that we've added in this heat pump supplemental heat section, heat pumps having supplemental electric resistance heat shall be certified cold climate heat pumps meeting the requirements that I just described. The ventilation section, we have removed the stipulation that ventilation should be either natural or mechanical, because our advisory committee stated that this was a little confusing to designers. And so we took it out because ventilation should include both natural and mechanical. So just for clarity's sake, we just have removed that description, and the sentence now just reads, ventilation shall be provided in accordance with ASHRAE standard 62.1. But there's no actual change to this section. Then thermostatic setback capabilities. It used to be in the 2015 that the setback controls shall have the capability to be set back, and now we have added that they shall actually be configured to have setback, and we've reduced the band, the temperature band. Instead of 55 and 85 degrees, we've set it to 60 and 80. So thermostat, controlled thermostats are now required everywhere. And the only exception is zone served exclusively by cold climate heat pumps, because a deep setback is more difficult for heat pumps to recover from. We've also taken out the stipulation that two-way valves are only required for the larger systems. We are taking that out and saying that the two-way valves are now required for all systems. Again, we want to ensure that VFDs are effective in all systems, and we're reducing the size that the motor size for VFDs. So now it also applies to smaller systems. So no more three-way valves. So this section, C403.3, heating and cooling equipment efficiencies, addresses equipment sizing, or that's the only place that we have changed anything. And the intent is to reduce the inefficiencies attributable to oversizing. So the output capacity of heating and cooling equipment shall not be greater than that of the smallest available equipment size that exceeds the loads, and sizing is permitted to be up to 10% greater to the next nearest available size than the calculated peak heating and cooling loads. And that is to allow for building pickup and cool down after temperature setback conditions. So this was discussed with the advisory committee and accepted to be acceptable to the design world of Vermont. So the next pages have some tables. I just wanted to point out that the plate type liquid to liquid heat exchanger is the test procedure is now listed in there. And here comes a bunch of tables that I'm going to go quickly through, but please feel free to pause this presentation if you'd like to study the efficiency changes on the page. As stated before, Vermont is required to comply with the federal standard efficiency levels for equipment, and so we could not change these. We could not make them any better. These levels match the IECC 2018 levels. So this table talks about the small AC units that they have an HSPF of 10. As you've probably noticed by now, I forgot to mention anything in red is where the changes are happening. Then this page covers the table for room air conditioners with their efficiency levels. This page covers the room heat pumps. Here we have the furnaces, both gas-fired and oil-fired, the AFUEs. Boilers, hot water and steam, only a few changes. One thing I wanted to point out, the minimum efficiency requirements, the IECC 2018 language was added to the notes section of this table, and that stipulates that a boiler cannot have a constant burning ignition pilot. And we have also added that a boiler temperature reset control strategy, so that boilers shall be equipped with an automatic means for adjusting the temperature of the water such that an incremental change in load produces a corresponding incremental change in temperature of water supplied. So that has to do with outside air temperature reset. More tables, the efficiency of closed circuit cooling tower. And here for VRF systems, the IECC 2018 added the IEER, so the integrated efficiency rating, for units greater than 5 tons to account for the seasonal performance at different capacities. Added efficiency rating for air-cooled VRF systems with heat recovery. And added the IEER for water source VRF systems. And here added efficiency rating for water source VRF heating mode, so the COP. Okay, that was it for the tables. The hot gas bypass and boiler turn down. So hot gas bypass was discussed in the advisory meetings, and it was accepted to remove for all systems. In the previous, it was it had some exceptions to that, but now we are prohibiting it in all systems. The boiler turn down, I'm mentioning here because other trainings had different languages for how we could rework this. But ultimately, it was decided by the consultants, by the advisory and the shareholder meetings, that we were not going to change the size stipulation for boiler turn down. So that is remaining ultimately as it was in the 2015 CBES. Heated vestibules is something that was added as a new section in IECC 2018, and we have added it here. We have modified it slightly from IECC to match what we here in Vermont are doing, and that is that The controls shall shut off the heating when the outside air temperature is greater than 55 degrees unless it's site recovered energy or transfer air that would otherwise be exhausted. Automatic start is something that's new to CBES. It was added to match the IECC 2018 section, and that is that controls are used to automatically adjust the daily start time of the HVAC system after an unoccupied time of setback or setup. Okay, so heat rejection, the advisory committee stated that this section was not very clear in CBES 2015, so this wording has been added and changed to add clarity. And feel free to pause this presentation to study the wording, but the intent is similar. It just hopefully is more well defined. The part load controls section, it remains the same. The wording is the same, but the sizing of the system has changed and the pump capacity for the variable flow has been reduced. So in 2015 CBES, it was 500,000 BTU system, and now it's 300,000 BTU, and instead of 5 horsepower pumps, it's now 2 horsepower pumps that require variable flow, so a VFD. Otherwise, the restrictions are the same. The opportunities are the same, excuse me. So part load controls. Again, this is where we are focusing a lot of our changes throughout that you'll notice, because we couldn't do very much with the mechanical equipment efficiencies themselves. So the changes here are the size of the motor where VFDs are required, and pump flow control is hopefully more clearly described than in CBES 2015. The wording was developed with the advisory committee, and so the whole thing is section C403.4.3.1 states that where pumps operate continuously or on an on-time schedule, they shall have a VFD for motors greater than 1 horsepower. And the next is, it states that pumps over 2 horsepower shall have VFDs if they are on DDC. Also, section 4 stipulates a differential pressure control sequence that reduces pump speed to maintain at least one valve nearly wide open. And this enables the pump to operate at a minimum speed, the minimum speed that's necessary for the load. Continuing with part load controls, but now the exceptions that were added is the variable pump flow is not required on dedicated coil circulation pumps that are needed for freeze protection. And they're also not required for renovations where more than 50% of the annual heat is generated by a pre-existing electric boiler. So then economizers, there were these exceptions, 5 through 9, and they have been removed. So economizers are now required in a lot more cases, and this was discussed and approved in the advisory and stakeholder committees. Then economizer fault detection and diagnostics was required in CBES 2015 as of 20 tons, and we've reduced that to be required as of 15 tons or greater. Then variable air volume and multiple zone systems. So this section has added a description of DDC control strategy for VAV systems serving multiple zones. And the 3 stages of heating using the DDC is what's in red here, that when the zone is satisfied and is operating within its deadband, the airflow rate is less than 20% of the design peak supply rate. And then when the first stage of heating comes on, the heating coil will increase the discharge air temperature, but the airflow will remain at its deadband airflow rate. If a second stage of heating is required, it will modulate the airflow rate to remain less than 50% of the design peak supply conditions. So you've got the heat coming on, the heating coil is on, but the airflow remains at its minimum, that deadband flow rate, and then it modulates up to 50% of the zone design peak to satisfy the heat load. Then this is a new section that follows the IECC 2019 or 2018, I'm sorry, and that is for parallel flow fan-powered VAV air terminal control. And that it shall have automatic controls that turn it off when required and how to stage it. So this is another new section, ventilation air heating control. The units that provide ventilation air to multiple zones and operate in conjunction with zone heating and cooling systems shall not use heating to warm supply air to a temperature greater than 60 degrees. When the outside air conditioned or the building loads have it that the majority of the zones are in cooling mode. So this is to avoid heating and recooling. Yeah. So here we have the energy recovery systems. It used to be that this applied to equipment over 8,000 hours or with higher design airflow rate. So we have reduced it so that the energy recovery is required in buildings that have more of an office type of operating hours, where it's say 8 to 10 hours a day, 5 days a week, so that energy recovery, it just happens in more of the buildings. So all of the requirements are the same. It's just that it's required now for smaller units and for units that operate less hours. Then this section doesn't apply for that many hotels in Vermont, but it's a new IECC section that controls hotels with 50 guest rooms or more, and its temperature controls so that during unoccupied times you have the temperatures set back. And more controls, again, for serving guest rooms that They will turn off ventilation and exhaust fans 30 minutes after occupants leave the rooms, but they allow for a purge cycle, either pre-occupancy or if rooms are not used very often and it needs to be kept fresh. So here, 2015 CBES did not stipulate a fan size for excuse me, sorry. So in this one, the HVAC system having a total fan system motor nameplate horsepower exceeding 5 horsepower at fan system design conditions shall not exceed the allowable fan system motor nameplate or brake horsepower. In 2015, the CBES did not stipulate a fan size, and so that has been added to this. Fan efficiency has been upgraded, that fan efficiency shall be not less than 70%, except for, as this shows, for fans of fractional horsepower or multiple fans where the combined motor nameplate is 2 horsepower or less. It was 67% for motors 5 horsepower or less, so we have increased the efficiency level slightly, and we have decreased the fan size that this is applicable to. And the fractional horsepower shall be either ECMs, electronically commutated motors, or NEMA premium efficiency motors. And the exceptions are where motors that are integral part of a specialized process equipment, or where the motor is integral to a listed piece of equipment where there is no complying motor. Otherwise, it remains the same as the language in 2015 CBES. Fan control, it was for units greater than 65,000 BTU, and now we have DX cooling for units 24,000 BTU. Shall have varying indoor air fan flow, so it shall have VFDs. Fan speed control, it was that variable speed was required when there were more than one motors totaling 7.5 horsepower, and we have taken that away, that it's just each fan system totaling 2 horsepower or more shall have controls that automatically modulate the fan speed. And here with cooling towers, the VFDs were required for 1100 GPM, and now we've reduced that to 550 GPM. And here we have new tables for the walk-in cooler and freezer door efficiencies. And you again can pause this and study this. So I just wanted to point out that the AND is the surface area of the non-display door, and the ADD is the surface area of a display door. And here are more walk-in cooler and freezer. And then the lighting for the walk-in cooler and walk-in freezer, it was 40 lumens per watt or more. And now we are saying that the LEDs shall have an efficacy of 90 lumens per watt or more. So we're just increasing the efficiency of the lighting so that not only is that more efficient, but also it reduces the amount of heat that is being put into these coolers and freezers. Duct and plenum insulation and sealing. So the buried ducts is the only part that is changed, and that was an R3.5, and it's now buried ducts shall be insulated to a minimum of R6. Piping insulation, it was between 60 degrees and 115 degrees. That piping did not need to be insulated, and now we have reduced that to between 60 degrees and 85 degrees. And that's shown here, that 40 to 60 is still the same insulation rate, but now it is 85 degrees that insulation is required. Protection of piping insulation is a new section, and it basically, you can read this, it's pretty straightforward, that just insulation exposed to weather shall be suitable for outdoor service. And so it doesn't deteriorate in our beautiful winters. And speaking of winter, we've got snow and ice melt system. It used to be that it was manual control. You could have manual control. And so we took out the manual. We're saying that it needs to be automatic, and it needs to be, whether precipitation is falling or not, but it needs to be measured, the slab temperature should be measured not less than 2 inches below the surface, so that all in told, the system is automatic, that it shuts off when the outdoor air temperature is above 40 degrees or the slab temperature 2 inches below the surface is 50 degrees or above. And that is it on the mechanical system. Thank you very much for listening. These are the highlights, and you'll be seeing the code in the beginning of 2020, maybe at the end of 2019. Thank you very much, and have a nice day.